Hello friends, welcome back to my channel. This is Venkatesh. Welcome to Smart Devops. Today we're going to talk about an interesting topic in Kubernetes where every person or every fresher or who wants to go for an interview for Kubernetes will well aware of these scenarios of different types of Kubernetes issues will come up in the day-to-day activities, how we can able to fix those. So before starting to that one, I just want to introduce again, like Kubernetes is just it's not just a container orchestration tool. It's a backbone of modern application deployment and management. To succeed in real-world Kubernetes projects, you must understand how to tackle scenario-based problems. So that's why in this video, we will discuss the top 10 Kubernetes scenarios every DevOps engineer should know, complete with solutions and practical insights. Okay. So before going to this video, if you didn't subscribe to my channel, please like, share, and subscribe to my channel to get this type of content on Kubernetes in future. Let's jump into it. So first one is pod crash loop backup error. As you know, when this issue will come, you deployed a pod, but it's stuck in a crash loop backup state. How do you debug and resolve it? And what are the steps you have to do and how you can, what are the scenarios? When you deploy a pod, it went into a crash loop backup. What are the steps you need to check to make the pod to come back to the running state? So let's take take you to that a live explanation of this crash loop backup state things. And I have given some commands here also how to check this pod logs, how to describe the pod details, and verifying those images and all. So I will show you that live check how to fix this type of issues and why this error is coming. Okay, let me take you to this. So I have a node. Okay. In this one, you see, I have a folder called testing. So simply, what I want to do, okay. So going to bring up, I'm going to bring up a deployment of Nginx, okay, and Nginx service into that one. Okay, so this is what just a simple for testing purpose I have created this template. Okay, now let me bring up this pod first. So now you can see a namespace called Nginx testing is created and Nginx deployment is started running. Let me zoom in for your, okay. So three things were started running now. Okay, now I'm going to see what are all the things running in the testing namespace. Now you can see the three pods were running and the service is started. And at the same time, the replica sets, how many replica sets we have. If you want to understand the basics of replica sets and deployments also, you can see my video. I did a thorough understanding of what is that each component in and what it is doing it. Now, what I want to make it here is, I'm going to edit the deployment. Okay, here I'm just doing a small tweak to make the pod went into the crash loop backup. What I'm doing here is I just going here and simply I'm adding something called command here, not giving something like some, it's something junk. Okay, just I'm giving here and just saved it. Now, what happened to the pods? Just watch it. See? The pod immediately went into the crash loop backup state. Because as I said in my PT, you can see here, what is the thing I want to mention here is your pod actually is connected to some memory and CPU limits, and at the same time for the configuration maps and secrets also. So if there is any mismatch in the namings, or it is not able to find out that respect to config maps or secrets, it will clearly say like I'm not able to find out the respective variable, respect to environment variable which you are expecting. So that's why it's keep trying to check for it. See, it's trying to check for every time, but it is unable to find out the respective command which I passed. So that's why it is keep on going into the crash loop backup. This is one of the scenario, but in live environment, you can see like if there is any config maps are missing, secrets are missing, and CPU memory mismatches. So if this happen, crash loop backup will occur. Now I'm going to fix this one. I'm going to remove this. Okay, just reverting the changes. Now you can see pods have started running. So this is the one of the scenario. Now I'm going to take you to the next scenario, that is intermittent pod connectivity issue. So that means you have the pods running in your cluster, but somehow the connectivities were not working as expected. Why? What is the criticality of the ingress and egress traffics between those pods? Why those pods were not able to communicate? So uh, these are the parameters we need to check it for this type of pod connectivity issues. So let me go for a live scenario. Now I'm going to delete this whatever we brought up here. So now what's the plan for me right here is I just want to bring up a Nginx again. Just I'm going to run it. I will show you how we can um, stop sending the traffic to the pod and start sending the traffic to the pod using network policies. Okay, that's what I'm going to do here. Simply, I'm just installing. Oh, sorry. Yeah. So it started running, and I just want to expose this Nginx deployment by running this command. Now you can see started running. So one pod for Nginx and a service for that one. Now what I want to do here is I'm just going inside the pod. Now I'm going to run a sample busybox. Busybox is like something if you want to you don't want to run any pod, extra pod, and you want to make a very minimal pod which will active for some time to test something. Like if you want to connect to other pod and do some activity like curl or ping testing, if you want to do, you can enable, you can make use of this busybox. It will be start and complete your action and it will terminate automatically. So now I'm going to run that. Now I'm going inside this busy box, and from that busy box, I'm going to connect the Nginx service, whichever is running here. So the command for running this one is, so you can see it's connecting download timeout, because the problem here is there is a Nginx service is stopped by network policy. Okay, so I have a network policy is already enabled and it is um, stopping the busy box to communicate to the Nginx service. Let me come out from this and check. So this is the Access Nginx netpol which is already running. So that's why let me show you what is the condition I set for this network policy. So what I'm telling here is you can connect to that Nginx service from any other pods, including the busy box or any other pods. you have to come with a label which is access equal to true. So if you come with this label only, I will connect to that respect to Nginx service. So let me provide you the respective things. So how I can do that is when I'm running this busybox run, right? I'm adding a label to that one. So I'm just adding a label. So hope you understand, right? Here I just ran the busybox, just a busybox to connect to the respective Nginx service, but it is getting timed out. Why? Because it's expecting a label to be passed so that I'm able to communicate to the respective Nginx service. Now I'm going to run the same command to connect to the Nginx. Let's see the output now. It's connecting, right? So you can see the difference here. It is connecting here and it is download timeout here. Because here I just pass the condition. If you have this label, just communicate, run the traffic to that respective pod. So that's the difference. How you can stop the traffic, how you can send the traffic by creating some labels, and you can provide the privileges to the namespaces. So that's why the network policies came. So this network policy concept is very interesting and very important. How you, when you need to send the ingress traffic, when you need to send the egress traffic. Okay. So to understand these things and all, you can run the curl command, ping command. It's not only wget command, which I used here. You can run the curl command also to understand the testing between the test connectivity between the two ports. Okay, and my tip for this one is like if you can understand this concept, the base core is you can check the CNA plugin also. That means your container network interface protocols like a Docker container which is already running. Okay, just to make sure that one. After that, this ingress or network policies will come into the place. This is about the intermittent pod connectivity issue. Next, I'm going to the next one. High pod resource usage. What is this? So it's very important that you can create a pod, you can run a deployment. But whether, for example, you have your node, CPU, memory, those things and all which is already there, and how you can able to calculate how many pods you can run. What is the limit of that respective pods you are running? Okay. Suppose imagine a pod is consuming excessive memory, which is affecting your cluster performance. What you can do, right? So by considering these things also, you should specify how much CPU and how much memory you need to provide for your respective pod. So that what will happen, even if the respective memory limit or CPU limit got increased, it can be managed by using a HPA. HPA is one of the pod which is running in your cluster that is really required for maintaining a auto scaling because I will show you the demo also next, but I just want to may understand you what is horizontal pod autoscaler. If you run this horizontal HPA, you can declare how far you can able to increase your pod for the, which limit. What is your limit of your pods? How many minimum replicas, how many maximum replicas? You can mention everything and you can run it so that you don't need to care. Like if the load is increased, this automatically scale up the pods from the minimum to the maximum pods. So it will act like auto scaling and it will reduce the memory reduce the load on your node. So let me take you to a demo on this. So if you see here, this is a Nginx thing. Here I'm just giving some command like a tail day zero. This is like I just want to put a uh, pressure on my node to make the containers to go down. Got it? So if it went down, you can understand how it is behaving, how the autoscaler is coming up into the place. And as I said, like I'm running a metric server, which is to If you run this pod, you can get how much memory, how much CPU will be allocated for that respective node. You can see here itself. And at the same time, if you see top pod, you can see that Nginx is the top pod which is consuming the 8 millicore of memory. Okay, this is one thing. This horizontal pod autoscaler for autoscaling is right. It's running it as a pod, and we can run it as an suppose if you are running for Ingress or something. So same thing for the horizontal pod autoscaler. You can start running this one, and whenever you have your applications like a deployments, when you start running on the Kubernetes, attaching to the deployments when you have autoscaler to that deployments, it really helps to maintain the health of the cluster, and at the same time avoid the frequent issues happening for the pods or communication issues, so node issues that can be minimized by using the horizontal pod autoscaler or doing an autoscaling. So next is persistent volume claim. As you know, I did a complete video on this persistent volume claim in my Kubernetes playlist. So what is happen when you create a persistent volume? First of all, what is a volume? As you know, in your desktop or in your machine, you have a volume separated for it, different paths, right? So same thing, you can create your own volumes in the Kubernetes cluster for specific storage. Okay. So you want to use, for example, if you take a MySQL application, you want to store some data which is coming from the user, you need to store somewhere rather than in the pod, you want to store it in somewhere in your machine, in your drive. So you can create a persistent volume. Okay, and you can attach that to the deployment. So whenever the pod got disrupted and it got stopped, but you can have you can have the data available in your machine. So that's the beauty of the persistent volume. And persistent volume, you can have a volume claim also that is called PVC. So you can add that volume to this PVC so that you can have you can claim some memory from that one for your utilization. So for example, if you give 10 GB for your claim and you can make use of that, it's not like you can completely use of 10 GB. You can use of some of the memory from that for your persistent volume for your application perspective. Okay. And even we have the different types of storage classes also. That is mainly for on-prem and at the same time cloud also. So when you want to use the storage from the cloud, yes, you can have the different type of provisioners available in the Kubernetes storage classes. So there are different types of issues will come, mainly like the bounding will not happen like when you start creating a persistent volume claim, but there is no persistent volume available for that respective claim. So at that time, it is still looking for that volume and it cannot bound to that respective persistent volume. And sometimes the storage classes naming will be wrong and the storage class will not be available. So in this type of scenarios also, you can see this type of persistent volume claim, not bounded messages. Okay, to run and see the details about the persistent volume claim or persistent volume, you can run this one and you can check out my playlist on the Kubernetes crash course. I have mentioned about what is persistent volume about. Okay, just go and check it. The next one is Ingress controller. The complete a video is there for the Ingress route, which I have created a couple of applications for a blog and store. So the main thing here is like why we need Ingress controller, like to reduce the number of load balancers, provisioning the number of load balancers in either in cloud or in the on-prem, so that uh, when you have your application, it will have a number of microservices. As you know that you can give that microservices and all the services by attaching to a hosting. For example, smartdevops.com. So under that one, if smartdevops.com slash some the service name, if you provide that, you will get the proper response from that service. So what will happen if you by mistake provided some wrong service name, if the service name is not at all running? Okay, so these things and all I mentioned in my previous video again. So you can describe your Ingress and you can make sure all the services are running, all services are properly named correctly. Okay. Before enabling that Ingress, make sure the respective service is running inside your cluster by doing a curl command, okay, before going to the browser. That's very important. So when you jump into the Ingress, that's a very big ocean. So for understanding, for debugging that Ingress, it will take some time. Before that one, better to check your service inside your and confirm that your service is working fine. Then you can attach that service to your Ingress host. So that's the best option I can suggest. So if you provide the different service names when you are bringing up the Ingress, you will get the different types of errors like 404 and 503 bad gateway. So this type of errors will come up. And the reason for this one is that's what I explained right now. Okay. And the main point I want to highlight here is never delete ingress route in a production environment. You can do anything on your development environment or testing environment, but don't never ever delete the ingress route in the production environment. Why? Because it will be attached to your load balancers. In AWS or in Azure, I can say it will be literally attached to your load balancer. When you delete that one, whenever you delete that one, a new host name will get added to that respect to DNS. Okay, that will get changed. So it will literally it will connect it to the route 53. Again, that's a different story. It will connect it to the route 53, and we have to configure that one. Those things and all are there. So to avoid that one, 99% don't delete the egress routes in the production environment. Okay. Development, you can delete it and you can create it for your testing purpose. Okay. That is the main issue is coming on the ingress controller when it is not routing a traffic to that respective service. Kubernetes not ready. That's what this error will come when anybody started building a cluster in his own mission. Why? Because we were doing Minikube, we're doing a Kubedium fashion to bring up the Kubernetes cluster. But after bringing up the Kubernetes binaries and all, the main point here is we need to bring up a network CNI tool. That's the Calico or a ViewNet pods. If you bring up that one, the internal network will get activated and it will enable the node to take the traffic. If you don't do that one, the node will go into the not ready state only. It will not allow any traffic to that one until that time. Okay, that's the main important point. Whenever you bring up the Kubernetes binaries, you should bring up the Calico or whatever the networking tool you are using it for your purpose. Service not exposing pods. This is what I said in the Ingress part. When you do the troubleshooting of the services inside the host, you will easily identify what is the issue before going to the Ingress. So do the curl statement and make sure which service type you are providing it, either it is the cluster IP or node port or load balancer. So as you know, this is a complete I mentioned in the playlist. Cluster IP is for the internal checkup, and node port is for external to the world. Load balancer is for the complete load balancing from the cloud perspective. So different types of things I explained in that also. So, but when the service is not working in the sense, these are the conditions we need to check thoroughly and make sure everything is properly set up. Resource exhausted. Resource exhaustion will happen when the pods were completely used that memory, and even it was crossed across that particular memory assigned. And the base problem here is provide the CPU memory thresholds in the pod so that it got exceeded and it was completely eating the CPU and memory of the node. So that when the node went down, when the resource is completely used, the node will go down. So that's why we are putting some taints and toleration for node. That means if you have a master and you have a worker will not have any taint. Taint is something like when you taint any node, none of the pods will go to that node. Okay, when you remove the taint, then pods will start running into it. Okay, that is the main use of the taints. Okay, and the toleration also, you can put a condition that when which pod you have to run, which application you want to deploy into that respective node. So that's a concept of the taints and toleration. So using these things and all, you can limit the pod usages and you can limit the utilization of that CPU and memory. The next one is pod stuck in pending state. Yes, again, when you have any CPU memory issues and the taints applied for that node and the respective resources were not sufficient for that pod to bring up, these things will come into the play and the pod will go into the pending state until we fix that one. Secrets and config maps not working. create your environment variables, you create your config map secrets. But when you are assigning that to that respective deployment, if you miss a name of that environment variable of the config map or secrets, it won't work. So make sure when you are creating the names, when you're creating the config maps and secrets, describe those details and make sure you are giving the complete exact path, exact name of that config maps into your deployment. When creating the secrets, make sure you are encoding that to the base64 format and keep it in your vault if you are maintaining it, those secrets and all. So this is the main thing. So finally, I just want to conclude this video. So mastering the Kubernetes scenarios, these are the very basic scenarios I can say. Okay, the top 10 scenarios. Anywhere you go, these are the top 10 scenarios will get come up, and even in your doing the day-to-day activities also, this these issues will come up for sure. Okay. So my only suggestion, my only takeaway from this video is this: simulate these scenarios in your test cluster, whether it is a Minikube or a Kubedium or kind K3, whatnot, whatever it is. And also share your insights and what are the issues you are facing it, other than these issues, and how you are fix that one in the comment section. Okay. So if you like this video, please like, share, and subscribe for more Kubernetes tips. And I'm going to come up with a new topic in the next video. Okay. Thanks for your support. Thanks for watching.